Hi, it's time for math. Easy solution here to discuss further into integrals and areas between curves and look at examples part 5 of this example series. And I'll solve this question here, which states basically find the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 1. And like I showed in my previous video, basically when you deal with stuff like this, it's best to solve this integral, solve the area by switching the variables to make it as a function of y, especially in this case because there's a y squared. If we had to solve the integral, if we just kept it as like this, we would have to write this as two functions, because in dealing with y equals 2 square root 2x plus 6 and y equals negative square root 2x plus 6, and I'll explain that further. Yeah, so now let's just graph these two functions first to show you just to show you what I mean. So if we draw the line y equals x minus 1 at x equals 0, y is equals to negative 1. So it's going to be a line like this, and this is going to be basically y equals x minus 1, and this point right here is at negative 1. I'll just draw this further up, and now this one right here, this parabola is well, basically consists of two functions pretty much, which is y equals square root 2 of x plus 1, and this is basically just a square root function. So if we put in inside this a negative 3, this becomes 0, so we go basically as far back as negative 3 right here, and basically a square root function is just going to be like this. Or in this case, all it is going to be a horizontal parabola. So it's going to just look something like this. Actually, it can't be that. So like this, something like this, and this is the y squared equals 2, 2x plus 6. And now the top part can be written as this, square root 2x plus 1, and the bottom is the negative square root 2x plus 1. So we want to find out what the area of this region is, and in this case, like I showed in my earlier video, I'm going to actually write both sides as functions of y. So we'll call this xr. This equals 2. We'll just solve this for y. Bring this to the other side, y plus 1. And now this one right here is going to be, I'll call this xl, or left, and that's going to be for the right. I'm just going to solve for x in terms of y. So this is a y squared. I'm going to move this negative 6 here, and then divide by 2 to take it out. Divided by 2, this would just be negative 3. So there's our function. Now we got to find these intersection points to write it inside our integral for these areas between. To find these, we just basically equate these two. So we equate these two functions, and the way I am going to do that is basically equating these two functions of y, just because it's already set up. So we just make them equal to each other, so xl equals xr at these 2 points, and that would be basically right here y squared divided by 2 minus 3 is equal to right here y plus 1. So now we just solve for y, bring this on the other side. I'll just multiply both sides by 2 actually first, just to get the 2 out. So we'll get y squared minus 6 equals to 2y plus 2. Move this over, we'll have y squared minus 2y, bring this over, negative 8 equals 2, 0. Now we have to basically solve for what y is, and like I showed in my earlier video on factoring, we would write y, and then this is going to be two numbers that multiply by each other to equal to negative 8. So they multiply to equal negative 8, but they add up to equal to negative 2. And in this one you could just think of it as negative 4, because negative 4 times it by positive 4 is equal to negative 8, but adds up to negative 2. So we get this right here. And now this is just equal to y. You can learn more on this in the video link below on factoring. And basically this equals to, now this is 0 when this side is 0, or this is 0, and this is when it's at y equals 4 and y equals -2. Just plug in -2 at 0, or 4 equals 0. So at these 2 points, and now at x is going to be equal to, yeah, well, the x values, well, we could just use this function, so that's going to be just +1 to each one. So we'll just go equals to 5 or -1. And so the 2 intersection points are at 5 and 4, and this one is going to be at -1 and -2, and this is a x, and that's y right here. Yeah, so now we have it at here. So then this y part of this one is going to be, well, -2. And now this part right here is going to be, this is just 4, because this point right here is x equals to 5 and y equals to 4. So that's x. Just to point out, that's x, this is y. And this one right here is -1 and -2. So now when we've written it like this, now we could basically set up our integral, and we'll call this area A. So A is equal to integral from -2, that's the bottom y, and then the top intersection point is at 4, and now the right function is xr, so that's y plus 1, and now we're going to subtract by this one right here, y squared divided by 2 minus 3, y squared divided by 2 minus 3, and then multiplied by dy, like I showed in my earlier video how to write this. And now we just simplify this even further. -2, 4. We could this is going to be +3, so add it to this, so y plus 4, take this bracket out, y squared over 2 dy. So now we can just solve the integral, and now we'll get, this is going to be integral of y is y squared divided by 2. And then this is going to be 4y, we just take a y up, and so when we divide by the power, this is going to be y3 divided by 3, but there's a 2 there, so 3 times 2 is 6. And now we have to add the numbers from -2 to 4, and cancel. Yeah, so already now all we do is just plug these in, so put a 4 over here, 4 squared is 16, then there's an over 2, then 4 times 4, that's a 16, minus 4 cubed, that's 64, divided by 6, and now we subtract with plugging in the -2. -2 squared, that's going to be positive 4 over 2, and -2 times 4 is -8, and -2, plug in this y cubed, -2 cubed is -8, but there's a negative there, so we go plus 8 over 6 right here. And now we just gotta work through the algebra to solve this. This 16 over 2 is 8, plus this 16 minus, just to make this easier on us, just divide this by 2 on both sides, 32 over 3. Now this one right here, take the brackets out, -2, 4 over 2 is 2, plus 8, and now we subtract negative, this is divide this by 2 as well, so we'll get 4 over 3. And now we just add this stuff up. So we add this one here, 8 plus 8 is 16, plus 16 is 32, minus 2 is 30. So 30, now we do minus 32 over 3 minus 4 over 3. Now this equals to 30 minus, now add these up, 36 over 3. And now divide the 3 out, we'll get 30 minus, this is 1, that's 2, 12. 12 times 3 is 36. So now we get 18, and that is our final answer. Yeah, but if we stuck with using functions of x like I explained initially, then we need to solve 2 integrals by breaking up y into 2 functions. So for example, we'll have this function on this graph like this. That's x, this is y. there is our line, which is y equals x minus 1. And now we have our parabola like this. Let's make this, it goes like something like that. Now we'll have two regions, because this is going to be y equals to square root 2x plus 6. And now this side right here is y equals negative square root 2x plus 6. So now we have to solve for basically the region between here. So we'll call this A1. And then this region right here, we'll call this A2. So we have to break it up into two. We have to find this point right here, and then we have to use basically this point right here as the in between. And that's for the first one. Then the other one you'll have to find basically from here to here for the second one. So basically we have to find two integrals. Basically two integrals to find two areas, and using these two functions and dealing with the square root, which would be just much more complex. So this method right here is switching it to y is much easier, and we get a simpler answer. Anyways, that's all. Actually, the answers will be the same, but it'll be simpler to get to the answer. Anyways, that's all for today. Hopefully you learned from this extensive example. And like always, you can download these exact notes in the link below. And yeah, like always, thanks for watching, and stay tuned for another Math Easy solution.